Okay, so let's talk about the ionization constant of a weak base. And here there is nothing special. There's nothing different from what we talked about. Now bases, like we said, they are elements that liberate hydroxyl ions as the only negatively charged hydrogen ion. So the negatively charged ions. So given a weak base BOH with concentration C. But you can do this. You can do this. Guys, thanks for the good work done. Yeah. So now you are given a weak base which partially ionizes, and the weak base is BO, where B is a metal ion and OH, that's a base. So this is aqueous. So it will give us B plus aqueous plus OH minus. So initially, okay, is it double? Okay, you have C concentration or the concentration. Pardon? Yes, initially we have, oh sorry, we have of the base, and since it is, we haven't done anything, it's not yet dissolved, then we have 0 B plus and 0 OH minus. But at equilibrium, you can write the whole word at equilibrium. Then if we form X moles of OH ions and the mole ratio is 1 to 1, then we shall form X moles of B plus, and that means B X moles, so the X moles of the base dissociated. But for us, we are interested in the number of moles of undissociated base, or in the concentration of the undissociated base, which is going to be the initial minus the concentration of the base that dissociated. So then from this equilibrium, then we can determine the Kb. And our Kb is going to be equal to the concentration of B plus times the concentration of OH minus divided by the concentration of B or H. Yes, this one is assumed. It is constant, it's the same. Not constant, but it is equal. Then we can just do the substitution. So we shall have our Kb, which is equivalent to the concentration of B ions, which is X, times the concentration of OH ions, which is X, divided by the concentration of C minus X, which is equal to X squared divided by C minus X. So this is our Kb, and that's how we shall determine our Kb. And we are going to see the example. Now if I'm to take you to the previous, this is where we made a simple mistake. Yeah, this is where we made a simple mistake. When here on the factorization, on the issue of factorization, this is C cubed, okay? And when we factorize, we shall put 1C and we shall remain with 1C squared. That's where we made a mistake from. And so therefore also this is C squared, and therefore this one is also C squared. Okay, and so we shall, even when we are substituting, it is going to be squared here. Okay, and so the answer must also be different. So this is the mistake that I wanted you guys to correct, but it was a calculation mistake. It was I just forgot. So even when you are deriving this, you still go ahead and do the same. Okay, I want you to derive this, you still go ahead and do the same. So now let's show the relationship between the Kb and the degree of ionization. And it is simple. Our base, our weak base, or our weak monobasic base, our weak base, BOH. Do you have the base? No, I don't think. Calcium hydroxide. Okay. So our weak base, it will still ionize to give us the BOH aqueous. It will ionize to give us the B plus ions aqueous plus the OH ions aqueous. Now, initially, you will have C moles of the acid and 0 moles of B plus and 0 moles of OH. But at equilibrium, if you come and titrate and find you at equilibrium, we shall have, if alpha is the degree of dissociation, if alpha is the degree of ionization, then at equilibrium we shall have alpha C of OH, but because it is the same, then we shall have alpha C of B plus ions, and alpha C of the base is gonna dissociate, and if it dissociates, then we shall remain with C minus the dissociated acid, which is alpha C. And so from our Kb, then you can determine the degree of dissociation, which is what you have done, which is what you have been doing. But let's do it chap chap. So this our Kb is going to be the concentration of B plus ions times the concentration of OH ions, everything divided by the concentration of BOH. Please, it is concentration. Okay? It's concentration. So if we substitute, our Kb is equal to alpha C brackets alpha C brackets divide by C minus alpha C. So if we factorize, we shall remain with C dot, okay, this is C squared in fact, let's not make the mistake again, alpha squared divide by C into 1 minus alpha. Okay, so if this C goes with 1C here, so we shall remain with C alpha squared C alpha squared divide by 1 minus alpha, it should give us Kb. Assumption, since alpha is far less than 1, then 1 minus alpha, it should give us 1. Okay, should be approximately equal to 1. And so what does this imply? It implies that C alpha squared C out of 1, it should be equal to Kb. So then what is your alpha? The alpha is simply the square root of Kb, okay, divided by the concentration C. So this is going to be your degree of dissociation of a weak base. So what is varying is just the K. The other one was Ka, but this one is Kb. Let's do some examples and then we got it. In fact, this could be the homework. Okay? Yeah, you have enough homework. Please do. You have calculate the degree of ionization of a 0.1 molar ethanoic acid. Ethanoic acid is written as CH. Let me use this. This is as CH3, CH, so the COOH. So it will ionize, it will lose this hydrogen ion. And it forms C ethanol with ions, COO minus plus the hydrogen ion. So that is ethanol. Then we have benzoic acid, the same. Benzoic, you have benzene and then COO minus. We have studied benzoic acid, come on. So it will also ionize the same way. Then we want an equation of ionization of methylamine. Methylamine, it's a weak base, CH3NH2. Okay? So its ionization, it will react, this is CH3NH2. Should I write it for you really? NH2 plus to dissolve in water, okay, aqueous, to give us, okay, CH NH3 with a plus and then plus the OH ions. So this is the ionization. Then from this we want the expression for ionization constant. You can do this, the concentration of this out of the concentration of this. Sorry, the concentration of this time was its products minus reactants. So the products divide by reactants, and since water is in large excess, yes, then you are given at 25 degrees Celsius, ammonia has a base ionization constant Kb of this. Write the expression of Kb. You already have it. No, this is ammonia, not ethylamine. And then calculate the concentration of OH. Now we want the concentration of OH ions. You have the concentration of ammonia solution. You have the Kb. And now we want the concentration of OH ions. And any assumptions made. And the first assumption, water is in large excess. The second assumption, the concentration of this is equal to the concentration of that. So if you do this successfully and I see your answers, I'll be happy to receive your answers. Otherwise, don't forget to subscribe, guys. Subscribe to our YouTube channel. In case there are no questions, then we can call it a day.